Okay, in this video we're going to talk about Unit 11, Objective 2, Radius of Convergence. What the radius of a convergence is going to tell us, it's really going to tell us half of an interval of convergence. So what that's going to mean is we're going to have some series that don't have just n in them. They're also going to have an x. And that series is only going to converge for certain values of x. We're going to find some interval over which x will be able to converge. An interval of x over which our series will be able to converge. And our radius of convergence is going to be half of that interval. Now, we're going to end up using our ratio test to find our radius and interval of convergence. And let's kind of take a look at what that would be. So we can say find the radius of convergence for the following series. So we'll say the series as n goes from 0 to infinity of n times x to the n power over 10 to the n power. Now, we can't tell right away using any of our tests if that's going to converge or not because it's going to be completely dependent on x. If x equals 10 or 20 or 30, the convergence of this entire series might be different. It might converge if x is 1, but diverge if x is 7. So we're going to have to find all of the values of x for which this thing will converge, and then we'll be able to make our interval and radius from that. So we want to use our ratio test to figure this interval out. So to use our ratio test, again, we're going to need to find a sub n plus 1. So in this case, that's going to be n plus 1 times x to the n plus 1 over 10 to the n plus 1. So then we want to think about our limit as n goes to infinity of the absolute value of that a of n plus 1 divided by our original one, or in this case multiplied by its reciprocal. And now we can try to simplify some things to make this look a little bit nicer. We have a 10 to the n, we have a 10 to the n plus 1, so that's going to leave us with just a 10 in our denominator. We have an x to the n plus 1 in the top and x to the n in the bottom, so that's going to leave us with just an x in the numerator. So just like when we were doing our ratio test, we can take that x over n out front because that's not going to make any difference on our limit because we're only plugging infinity in for n. The only difference here is that our x has to remain inside an absolute value. So the absolute value of x over 10 times the limit as n approaches infinity of n plus 1 over n. So if we take that limit, so we're looking at horizontal asymptotes, we get 1 over 1 again. So that's going to be 1. So our limit's just going to be the square root of x over 10. Now, thinking about our ratio test, we want this series to converge. So if we want this to converge, if we're going to force this to converge, we have to make sure our limit is less than 1. So from the beginning, we need to be thinking about our limit being less than 1. Right? We want to find when this is going to converge, so we're going to force it to converge. We're going to make sure our limit's less than 1. So if we look at this and we solve, we're going to get the absolute value of x is less than 10. So if you remember anything about solving absolute value inequalities, this is going to be equivalent to negative 10 is less than x is less than 10. So that is going to give us our interval of convergence. Which means if we take any value of x between negative 10 and 10, plug it in, our problem from the beginning will converge. If we take any value outside of that interval, so say 11, our series is going to diverge. So our interval of convergence is everything that is going to let us converge. Our radius is going to be half the distance from each endpoint. So from -10 to 10 is a value of 20, so our radius of convergence is going to be 10. So the radius is going to be 10. So again, what we want to do to find our radius or interval of convergence is we want to use our ratio test and force the series to converge. So we're going to make sure our limit is less than 1, solve for x, that's going to give us the interval, find the distance between the two endpoints, and that's going to give us the radius of convergence. So we'll call it quits there for this video. We'll see you in the next one.